welcome back, everyone, to another episode of ShiftED podcast coming to you. We're kind of at this crossroads between spring and winter just doesn't. And I have Tessa Forshaw here. And Tessa, you're down in Boston area, right?
Yes, I am. And we're also at that spring, winter. It can't decide. It pretends it's warm and then it's cold again.
Yeah. Like, no, the snow's all gone. Oh, here, have some more snow. Have some. It's like been insane this, I guess I'll put quotation marks, spring. So I have Tessa Forshaw here with me, cognitive scientist via Harvard, co-founder of the Next Level Lab, and author of an amazing book called Innovation-ish, which we'll get into. Cognitive science. So Tessa, I'd like to start these off with, what are some of the big moments that got you to where you are today? If you could, I know there's many that can contribute to, but what were some of those big moments that kind of changed the course of your journey in cognitive science?
Yeah, it's a great question. So, for me, the reason I started studying cognitive science comes from early on in my career. I worked in consulting, and the nature of consulting often is that you are put on projects that maybe you don't have a lot of expertise in. And that's not a criticism. I think there's a lot of benefit in the manpower and the collective thinking and the peripheral participation, and all of those things. But as a junior, sometimes, you're put to support experts in a project that you know nothing about. And in this situation, I often found myself designing either organizational learning or really big workforce development, transition programs that were great in terms of their goals and their missions and what they were trying to achieve, but with no understanding of how a person's brain learned. And that sort of started to feel funny to me. I was designing this stuff and I was like, well, it looks pretty. The deck is nice and the learning objectives all laid out in Bloom's taxonomy. And, I've done all of the things I'm supposed to, but I'm not actually sure if this is how a brain learns. And so I decided to go to Stanford to do my master's in their learning, design, and technology program. And within that program, I worked very closely with Professor Ropey, who is a cognitive scientist and learning scientist. And that was sort of how I started to enter into the discipline of cognitive science, because I really liked the idea that it was sort of about situating the mind in between sort of this idea of the biology and the neurological structure of the brain. And then the other side sort of being the behavior or the psychology. There was this idea of the mind. And yeah, that was why I started studying it.
That's wicked. And kind of what you're just talking about, these kind of two halves of our brain. And I know in Innovation-ish, you kind of debunk this myth, because I hear it often with teachers of, oh, I'm just not the creative type. Oh, no, I don't, and I'm like, is that possible? Can you help clarify that cognition and, I guess the more analytical side versus the more creative side coexist?
Yeah.
In all of us.
Absolutely. So I think there are so many neuromyths about how people's brains work. And one of the most common ones is absolutely this idea that, if you're right-brained or you're left-brained, and if you're, I always get it the wrong way around, but if you're right-brained, you're supposedly creative, and if you're left-brained, you're supposedly analytical. And in cognitive science, this idea is called personality-based hemispheric dominance. And there have been dozens of studies by hundreds of academics that looked at thousands of fMRIs, and there's absolutely no evidence whatsoever to support this idea that you are either right-brained or left-brained or creative or analytical. And I think one of the ways that I've come up with of teaching this, because similarly to you, Chris, I encounter a lot of people who believe it, but also have an identity sort of built around this myth. So a way that I often talk about it is, I love the ballet. I can't dance it to save my life, but I love going to the ballet. And And I think choreography or being a choreographer is probably one of the most creative acts out there, except that it is also an incredibly analytical act. You have to think about multiple people, how their bodies move through space. You have to think about time in, beats and sub beats, and you have to think about staging and movement and how that sort of works and comes together. You have to think about angles. Like there are so many, you have to go in on details, and then you have to be able to go back out to the big picture. All of those kinds of skills are inherently what we would call analytical skills. And yet they are at the center of one of the most creative professions that you can probably come up with. And then on the flip side, one of my colleague, Rich, who I co-wrote Innovation Niche with and I teach with a lot, he introduced me to this great story about Apollo 13, I believe it is, where they had a CO2 scrubber that broke while they were in space. And so they had to get all of the engineers on the ground in a room to come up with a new CO2 scrubber. And so what they did was put all of the found objects that are on the capsule, so everything that you could find, and they put it in the room and they said, come up with it. And they came up with multiple prototypes that could work and then ultimately refined to pick the best one. But that act of like, okay, I have these objects, let me come up with multiple different ideas, abundance, try things, see what could happen, be creative and potential, and use things in ways that are alternative uses to what they're designed to be. That's incredibly creative, even though, we think of engineers as especially space engineers, as very, very analytical. So, that's I think a really good way to think about it is nothing out there exists as one versus the other.
Right. I love your example too of the ballet, because I also go to the ballet, and, sometimes if you think about those details, if you don't, they're going to be crashing into each other. And like you turn the creative beauty into like a traffic jam, like it's necessary to, I guess feeding off of that, I do a lot of work with lifelong kindergarten at Harvard, through Mitch Resnick, through Scratch. And I love that we have this creative kind of glory in these younger ages, and it's these kids, what they do through play and creative. And I mean, what happens in adulthood to get a person from when you're 4 or 5, I mean, you're all seen as kind of creative, like, oh, look at that child doing these interesting things and thinking of different stuff. What happens as adulthood seeps into our lives, and this established kind of idea that you lose creativity rather than reinforcing it like a muscle where you work it out? Can you talk to that a bit, Tessa?
Yeah, absolutely. And just to say, Chris, I see this too a lot. So often I teach adults, and I always ask this question with my co-teacher at the beginning of a class, whether it be a class in a university setting like the Harvard Innovation Lab or Stanford D School, or a boardroom. We'll say, hands up if you think you're creative. And we usually see anywhere between sort of 10 to 25%, 25% like very rarely, but 10 to 25% of hands go up. I asked this in my daughter's kindergarten classroom, and she goes to a independent school that is very sort of curiosity, project-based learning. And I asked, like, hands up if you think you're creative. And it is not a joke when I tell you that every kid's like had 2 hands in the air. There were feet in the air. Like these kids were like bursting to tell me how creative they were. And that is such a stark difference, isn't it?
Yeah, totally. Like what happens?
Yeah, exactly. And so I think there are a few big things that happen throughout our lives. So one is cognitive, and then the other, I think, is more environmental. So from a cognitive perspective, as we start to go through puberty and into emergent adulthood, and I think this usually starts to happen about 12, we start to prioritize things like social cohesion, membership of the group. That's why you often see like young girls who want to look like all the other young girls, right? This idea of like belonging, social cohesion, not standing out, being accepted, part of the group. That's actually a survival instinct that has served us so well for like hundreds and thousands of years. Like if you think about it, when you're like 12 or 13 and starting to become an adult, signaling to your tribe that, hey, like I am a amiable group team member, happy to play and assimilate to our rules and ways of existing, kept you like in the tribe and not off by yourself. Like that is a great thing. And so that sort of cognition, that sort of cognitive development is quite natural, and that starts to happen. So that's sort of one thing. The second thing is that we also, I think, sometimes unintentionally optimize for obedience and ease and the collective over creativity. So what I mean by that is like, in many schools, there's dress codes or uniforms or rules around what you can and can't wear, all sorts of things like that. So that's saying like, hey, play within these boundaries, don't express the individual. In Australia, where I grew up, most schools actually have like a proper uniform from 5 through to 18.
Right.
Mine was a lovely color that was called poached asparagus.
Oh, wow.
So you can imagine how delighted I was at that. But so you get sort of taught, in workplaces, we often think about like assimilating to the company culture and the company values. Parents often want the child to like do the thing that I'm asking you to do and do what I say. And these are not criticisms. It's just to sort of say that we end up with this kind of confluence of factors where society is saying, don't express your individual creativity, sort of go with what's known, with the status quo, be part of the group. And your cognition is also sort of going in that direction. So when you put them together, that means that we start to take less risks and be a little bit more cautious in our cognition.
Right. But I mean, I think in the times that we're living in now, with the advent of AI coming in, and I mean, just so much stuff happening in the world, that creativity would be something that we need to rely on so heavily right now to navigate ourselves. Why does it seem to be creativity always this fringe that, like it's like one or two of, the kids that dress differently, or like, two different, but it's not the majority, like you're saying. Where does that kind of creativity start to be needed again, just to help solve some of the problems? And I love this idea too, that you were like talking about the bigger picture and then focusing in on the detail, and the creativity in those details is so important. How can we start to salvage creativity almost within our society that we're living in nowadays?
Yeah. I think the very first thing is often just to name the baby, so to speak.
Yeah.
So I think naming like, hey, we all face in our book, Innovation Nutrition, I call it innovation hesitation. We all sort of face this innovation hesitation or this cognitive caution. So let's just name that and acknowledge it so that we can start to work from it. That sort of principle comes from a lot of cognitive behavioral therapy with things like anxiety or panic or things like that. Very effective way of managing it. The second step is then often to name and to help, I find, students see and be empowered that actually everybody does have the skills to be creative. So creative problem solving really requires 3 key cognitive processes, a few more for sure, but like 3 kind of key ones. And these are not individual parts of the brain, but instead sort of networks that are how the individual parts communicate to manifest into achieving the mind, so to speak. So the first is what we would call divergent thinking. And that is definitely the most famous cognitive process. So if you think about diverging, it's about going up, abundance, coming up with wild ideas, going away from what's known, being crazy. I often use the analogy of aerodynamics. And in this analogy, it is lift. It's the going up into the sky. It's the hero, right? Like the plane taking off. But just like with an airplane, if you take off, but you never come back down. Like, that's not great, right? And so in creativity, we also need the other process being convergent thinking. So narrowing, focusing, analyzing, what's often more considered an analytical skill, but thematically clustering things, figuring out patterns or trends, making decisions and choices. So and so that's how we get back to the ground. But if you only go up and down, you're not really going anywhere in your flight, right? And so that third process is executive function. And so that really is what it takes to sort of plan and sustain and follow through on things, to think about your own thinking, to be metacognitive, and to analyze your choices and your flight path and your decisions. So in this analogy of aerodynamics, we obviously have lift, we have weight, and then we have thrust. And once you know those three cognitive processes that a child and an adult, like we all have to varying degrees, then, you realize that we can manipulate them to help us overcome air in the context, or drag in the context of aerodynamics. But in this context, innovation, hesitation, that sort of hesitation that we have to engage in creativity and innovation. And I think what I find interesting about these processes in operationalization is, if you're in a classroom teaching creative problem solving and you notice that there are students who are stepping out, or, stepping back a little bit, or sitting down and not engaging, and maybe they have a self-belief that they're not creative, or they don't feel like they know how to do it. One of the greatest things to remember is that of these three processes, everybody generally has a strength in at least one of them. So if the student group that you have, like, there's someone who's really good at the divergent thinking, and then there's somebody who's really good at the convergent thinking, a strategy to get them started into participating in innovation can be to have them say, all right, well, we're going to do the brainstorming first. So you take this, you take on that. But then, hey, student B, you're so good at making choices and coming up with frameworks and making sense of stuff. So I want you to take the lead on the next step. And that way you sort of bring everybody in to start to participate in creativity through their strength. And then slowly over time, you can help them take on some of the other processes that they feel like they might have a weakness in.
Yeah. It sounds like just a lot of practicing, like practicing ways that maybe we haven't thought before, or pushing our comfort zone a little bit. And I love in your book, you say, start somewhere. I guess that's what you're getting to here, is that you've got to find a place where you can start, where you're comfortable, I guess, because you're going to have to give a bit. You got to start, but then it can start to flourish as the more you practice it.
Mm-hmm.
Is that a fair statement, that the brain, and we know so little about the brain still, eh? It's like it's such a mystery at times, but you make such clarity happen thinking about cognitive abilities that we have. Is the brain always just looking for practice, like reinforcement? I know that you had said one time that if you get new information, your brain is going to go and access stuff that might connect to it somehow, and that's how you start to make understanding. Tess, can you flush that out a little bit more about how new stuff interacts with the old stuff in our brain to create something that is new, or a place to start, somewhere to start?
Yeah. So you hit it on the head. The key in all learning is to bring forward what a student knows, and then to bring the new knowledge into that same space and have them interact. And when you connect new knowledge to existing knowledge, you get much more durable learning. In the context of creativity, this is really true as well. If people bring forward what they already know and think and have ideas about, and then you start to interject new prompts or new concepts, or different people who think differently about the same stimulus, those interactions are part of what help us come up with novel ideas. And so in creative problem solving, especially in teaching it, one of the most important things I think to do is to help students start by bringing in what they already know. So often I will start with really vague prompt at the beginning of class, where I will say, here is the problem we're solving creatively today. I want you to go in your groups and spend half an hour coming up with a plan about how you're going to approach the problem. And so what that does is bring forward what they know about creative problem solving and problem solving. And then we start to learn new things about how to do it. And those new things connect to that existing knowledge so that when it goes back into their archival memory, they're connected. And that's really helpful because then the next time they get prompted to do creative problem solving, the stuff they already know very well is going to come forward, but this time it's going to bring that new stuff with it. And that's a really exciting sort of prospect. But if you kind of remember that idea of always starting with helping students figure out what they know about a thing and then connecting to it, and even if what you're doing is correcting it, starting with what they know is better than trying to correct it without teach them the new thing without bringing forward the old thing. Does that make sense?
Yeah, totally. I just had an aha moment when you were talking about that, because I always say relationships with teachers, with your kids, with the students. Build relationships, get to know them. And now I'm starting to realize why we say that all the time is that we need to access their experiences to bring them in almost, right? It's like an invitation for learning or deeper learning to happen. Is that a crazy aha moment?
No, it's spot on. And actually in my own research with adult learners in workplace settings, one of the biggest predictors that we found of their ability to transfer existing knowledge to a novel task, so a role or a task they've not done before, which I'm sure you appreciate is happening all the time at the moment. We're taking on things we didn't know how to do before. One of the biggest predictors was actually their more experienced other. So in a classroom, that's often the teacher, but the more experienced other helping cue them to see that they could bring that existing knowledge forward. And that there was similarity. And yeah, sure, there was difference too, but helping them sort of pull the threads of that reasoning. And when they had a more experienced other that did that, they were more likely to successfully transfer the knowledge as measured by the time that it took for them to get to competency and their performance on the task.
Amazing. Wow.
Yeah.
I got to go back now and listen to more of you and and I'm going to pull Innovationish back out. It's so fascinating. I really, really appreciate this conversation, Tessa. It's been enlightening for me. I always have questions ready, but I think that our conversation touched on most of those and also some really insightful ideas around how we learn and how creativity fits into all this. I thank you so much. This is a great opportunity for us to start thinking about the brain a little bit more and how it works. And that, surprise, surprise, we're all creative. It's what you do with it.
We all are. And that's, I think, my parting guidance is that if you come across a student who doesn't believe that, from as young an age as possible, help reinforce that that's not true. That's, I think, the best gift we can give young people heading into this wild and uncertain future is to be empowered in their ability to creatively problem solve.
Amazing. Thank you so much.
Take care.